Hey everyone, this is a quick video about the homework that was due tonight. Thanks for your feedback in that survey. We aren't going over homework like we used to, so this will hopefully help. But I'm going to do this as quickly as I can, so you pause the video as you see fit. Now for that first circuit, we are told that there are 20 amps going through that first ammeter. And what you need to know is, or what you should know is that in series, because these are in series, the current is the same everywhere. So I'm actually going to write 20 amps and 20 amps next to each resistor. Now, if I know the current and the resistance, I could also, if I wanted to, write down the voltage, because V is just IR, so this would be 440 volts. This would be 300 volts. Again, all I'm doing is V equals IR. That's basically the gist of it. Now, as for the other questions, I'm hoping you were fine answering question A, which was just adding the two resistors together, and you get 37 ohms. That's nothing crazy. Now, the total voltage, you have a couple choices. In series, you should know that the total voltage is the sum of the voltages. That's from the activity that you did. So however many there are, that would simply be 440 plus 300 gives you 740. And then if you wanted to, you could also do the voltage of the source equals the current coming out of the source times the equivalent resistance. So V equals 20 amps times, what is it? Sorry, 37 ohms gives you 740 volts. That's up to you. As for question C, you're just solving for power. Now, I've already posted the homework solutions for this, so I don't want to waste too much time. But you do have like all the information you need. You have oops, sorry, wrong resistor, and we're not going to be editing this, so let me try that again. You have the resistance, you have the current, and you have the voltage. So for C, it is completely up to you if you want to use P equals IV, I squared R, or V squared over R. That's completely up to you. And then the next question is, what is the power of the source? So if we're talking about source power, that's just power of the source. I would do the current coming out of the source and the voltage of the source, which would be 20 times 740. That's, again, up to you. Or you could do I squared R. That'd be I squared R equivalent. Or you could do V squared over R equivalent. That's up to you. E, the last question, we've already answered. So I'm going to move on to the next circuit, which was the parallel circuit. Now, in parallel, you should have realized that the voltage is the same. So I'm going to write that voltage here. It's 110 volts, which means this is also 110 volts, this is 110 volts, and this is 110 volts. Simply using V equals IR, Ohm's law, you can quickly do math and figure out that V over R for resistor, the 20 ohm resistor is 5.5 amps. This would be 2.2 amps, and this would be 11 amps. I'm learning how to do math. Sorry about that. So after that, it asks for the current in ammeter 1. Well, you should know that the current, as it flows around, it then splits up and goes through the 3 resistors. All that current that's flowing down through these resistors then joins up and all goes through A. So also from the previous activity, you should have seen that the total current is the sum of the currents. So A1 is simply the sum of the currents, which I apparently screwed up the first time when putting out the homework because I can't add like a normal person. So that's pretty straightforward. It then says which resistor is the most powerful. From our previous activity, something you should know. Sorry. So in parallel, voltage is the same everywhere. So if we're looking at power, when it comes to parallel, I often think of power equals V squared over R, because if this is the same for all of them, then the smaller R, the bigger the power. So to answer question E, it's just 10 ohms. And then again, it's up to you which equation you want to use. There's no right equation, but you do have R, V, and I. So you can use P equals IV, you could use I squared R, you could use V squared over R, like whatever you want to do, use those values to get the power. And that's about it. So moving on now to the brightness ranking. Okay, I'm going to do these rather quickly. So the first one here should be pretty straightforward. The current comes out, doesn't have a choice where to go. They're all in series, so that means they're all the same. A equals B equals C. Most of you did get that correctly from what I've seen so far. This one here, the current comes out, but then it's going to split. So some of it goes up through B, and then some of it is, and then, sorry, then it rejoins after that junction. So it splits at the junction. Sorry, my pen is not writing, and I don't know why. Sorry about that. So it splits at the junction, and then rejoins and goes through D. So the order is A equals D, and then B and C get less because the current split, again, at this junction, so it's getting less. Working our way over, let me move this over here. Here, just tracing the current, it all goes through A, so A gets everything. Afterwards, it's going to split. Now, just think about this as if it was a traffic light. You're trying to get back to the other side of the battery. Do you want to go through one resistor and back to the battery? Or would you prefer to go through, I don't know, 2 traffic lights and get back to the battery? So again, it's like you're trying to drive home and there's either 1 or 2 lights to go through. So if that makes any sense, current splits here, most of it is, or I shouldn't say most, but more of it will go to B, and then the other parts will go to C and D, who are in series with each other. So the order is A, B, C equals D. And then the one down here, current comes out, reaches a junction, it then splits. Some of it is going to go through D. Again, using that traffic light analogy, you're trying to get back to the other side of the battery. Which route would you rather take? You want to take the route with the least traffic lights. So D provides the least number of traffic lights, so more of the current will go there. So that's D. Now, for those that have handed in, some people got this wrong and said D equals A. That's not the case. Actually, most of it goes through D, and then some of it goes through A, and then it reaches another junction where it splits again. So that means that A will be getting the next most, and then, sorry, it's the same color as before, splits between B and C, rejoins here. I don't know why the color didn't change, but I'm not so worried. Either way, the order is D, then A, then B equals C. Most of you did get it right. The most common wrong answer was that A equals D. And the last one up here, this is tricky. Not gonna lie, this is something special. The current comes out, it goes through A, and then it reaches a junction. Now remember, you are in a car and you're trying to get home. You have 2 options. You could go through no more traffic lights and get home, or if you wanted to, you could try to go through 2 more traffic lights over here and get home. As it turns out, these don't even go on. It's only A. The other 2 are off. That's because that vertical bar, bless you, the vertical bar in the middle here has no resistance. It's called a short circuit. It's basically like an unimpeded path with no resistance. So would you rather go through no resistance or 2 light bulbs? Would you try to get home by going through no traffic lights or a couple traffic lights? Now, some of you may be asking, like, doesn't a little bit of current go through B and C? No, no current goes through B and C. It all goes through that short circuit. So that's a little tricky. Other than that, that's a summary of the homework for tonight. And if you have any questions, of course, find me at Google Meet at the allotted times. If you want to set up an appointment with me, you can. And otherwise, just send me an email. Hope you're doing okay.